Good day, everyone. This is Ma'am Jo de la Peña, and welcome to another video lesson discussion in statistics and probability. Before we proceed to our main discussion, let us define first experiment. So what is an experiment? Okay, in the field of science, we refer experiment as a procedure designed to test a hypothesis, or to make a discovery, or to demonstrate a known fact, which is part of the scientific method. Now, in mathematics, we define experiment as a trial, procedure, or any activity that can be repeated and that has a set of possible results. Now, take note of the word repeated. So, what are examples of experiment in mathematics? One, we have tossing a coin. So, we can do tossing a coin repeatedly, okay? And the probable results could be using a Philippine coin, we can have a head or tao and a tail or ibon. Okay? We also have rolling a single die. Okay? Die is the singular term for dice. Dice if you have two. Okay? So when we roll a single die, we can have a result. It could be the number 1, 2, 3, 4, 5, or 6. And you can do it repeatedly. Now, if we roll 2 dice, okay, we can have 2 numbers, which is the result. For example, we have 3 and 4. Okay, so another experiment in mathematics is drawing a card from a deck of cards. So there are 52 pieces in a deck of cards, and we have 4 designs. We have the color red for heart and diamond, and for the black we have the flower and the cup, or the flower and the club, or the spade. Ayan. Now, when we draw or when we choose a card, okay, we can draw a card. For example, we have a queen of flower. So we can do it repeatedly. Now, there are other experiments in mathematics that we will be discussing as we go on with the topic. But these are the most commonly experiments that we can do repeatedly. Is that clear? Okay. There are words related to the word experiment in mathematics. For example, our experiment is rolling 2 dice. Okay? The first word is the sample space. So it is the set of all possible outcomes or result in an experiment. So all, you can think of all the numbers that will come out of when you roll 2 dice. So in rolling 2 dice, you have 36 possible outcomes. So it is listed here. Okay, so you have 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, and so on and so forth. And you denote sample space as S of n. So S of n is equal to 36. So there are 36 possible outcomes in rolling 2 dice. Now, another word is the word outcome. Okay, so in rolling 2 dice, the outcome in the experiment is 4 and 3. Okay, so this is the outcome, 4 and 3. Now, on the other hand, when we say event, this is a subset of a sample space. So when we say subset, that is just part of the sample space. And you can see those subset in that event here. Okay, for example, our event is you have to roll 2 dice 3 times or thrice. So the event is you have to roll it thrice. Okay, so on the first event or roll, so the outcome is 4, 3. So this is the element. On the second roll, or the outcome is 2, 5. And on the third event or roll, so you have 6, 4. So since we only roll the dice thrice, so we can write the subset or the event this way. So you have to enclose the 6 or the 3 outcomes in a bracket, since this is just part of a sample space. So for 3, you can see it here, this one, and then 2, 5, you can also have it here, 2, 5, and 6, 4, you have here. So event is just part of the sample space. outcome is the result of the experiment, and sample space are all the possible outcomes. Is that clear? Okay, so I hope you can differentiate one from the other, and you have to use the proper notation for sample space and for the event when you list all the events in the experiment. Is that clear? Okay. I have here a 6-letter word wherein 3 letters are missing. Using the clues above, what do you think is the word? Okay, so the word is random. So when we select or choose something by chance, we say that it is randomly selected. Meaning, there is no rule or pattern on how you're going to select it, just random selection. For instance, here we have a bowl of numbers. So whatever number that will pop out of the tube, that will be the chosen number. Here, if we're going to spin the wheel, okay, and it is stopped in a particular number, for instance, you have here 1,000, so that means we're going to use the 1,000 or pick the 1,000. Okay, so that is what you mean by random selection. So this is a common activity in TikTok and Instagram, wherein there is a question in your forehead, and then something will just pop out just like this one, hair, face shape, and eyes, and then whatever is the chosen word, or whatever, when it is stopped, there is a chosen word or answer to the question. So you just do it randomly. Is that clear for the word random? Okay, so our topic for today is about random variable and properties of a discrete probability distribution. And these are the objectives of the lesson: distinguishes between a discrete and a continuous random variable, illustrate the probability distribution for a discrete random variable and its properties, and computes probabilities corresponding to a given random variable. So when we say random variable, it is a variable whose possible values are determined by chance. It is a result of chance event that you can measure or count. It is also defined as a numerical description used to quantify outcomes of random occurrences, just like any statistical experiment. Example is rolling a die or tossing a coin and the likes. Okay? So it is a quantitative variable wherein the values depends on change or chance. Okay? It is usually represented by an uppercase letter or a capital letter, while its corresponding lowercase letter or small letter is used to represent one of its value. So this is how we define random variable. There are two types of random variables. Since it is quantifiable, it could either be discrete, which means having specific values, or countable, or continuous, which means it is any value in a continuous range, or it is measurable. So when we say countable, you can use your fingers to count it. And in continuous, you have to use measuring devices to get the value. Okay. Now, example of discrete random variable is the number of defective chairs or the number of red balloons. Okay. So those are countable. Now, for continuous, we can have the amount of drugs prescribed by a doctor, which can be measured by grams, okay, or milligrams. Or we have temperature. You can have Celsius or degrees Celsius or Kelvin or degrees Fahrenheit. Another is the distance, height, and weight. So those are continuous random variables. So you have to use measuring devices, and here in discrete, you just use your fingers to count it. Is that clear? Okay. So what is a discrete probability distribution? It is also called a probability mass function. So it is consists of the values of a random variable that it can assume and the corresponding probabilities of the values. Okay, so take note of that. So a probability distribution consists of the possible values of the random variable and its corresponding probabilities. So let's have now the properties of a discrete probability distribution. I have here a probability distribution table wherein you have here the random variable x and its possible values, which are 1, 3, 5, or 7, and p of x, which is the corresponding probabilities of the random variable. So for 1 you have 0.35, for 3 you have 0.18, for 5 0.22, and for 7 you have 0.25. Now, there are two properties of a discrete probability distribution. The first one states that the probability of each value of the random variable must be between or equal to 0 and 1, or in symbol, p of x, or the probability should be greater than or equal to 0 but less than or equal to 1. Okay, so looking at the probabilities, so you have here 0.35, 0.18, 0.22, and 0.25. These four values are all greater than 0 but less than 1, or they are between 0 and 1 but not greater than 1. So the first property is that one. For the second property, the sum of the probabilities of all values of the random variable must be equal to 1. So in symbol, you have here the summation sigma p of x is equal to 1. So what does it mean? If we're going to add all these probabilities, so you have 0.35 plus 0.18 plus 0.22 and 0.25, this should add up to 1. Okay, so when we have the sum for this, it should be equal to 1. Okay, so this one is equal to 1. Okay, now these two properties must be satisfied. If one is not satisfied, okay, if the first property is not met, so this one is not a discrete probability distribution. If property number 2 is failed or false, this one is also not a probability discrete probability distribution. So those two property must be satisfied in order to have a discrete probability distribution. Is that clear? Okay. Okay, let's have an example. Determine whether the distribution represents a discrete probability distribution. For number 1, this is the table. So for property number 1, just look at the probabilities. It should be greater than 0 but less than 1. So 1/6, 1/6, 1/3, 1/6, and 1/6. This is in fraction. So if it is a proper fraction, meaning the numerator is smaller than the denominator, so that means it is less than 1. Okay, now if the numerator is greater than the denominator, okay, so that means that is an improper fraction, or it is greater than 1. And if you want to make sure that it is less than 1, you can convert it to decimal. So you just simply divide 1 divided by 6. So this is the value. These are the values for 1/6 and 1/3, and you will notice that it is less than 1 but greater than 0. Okay, so property number 1 is met. Now for property number 2, if we're going to add everything, so we can convert 1/3 into a similar fraction. This is equal to 2/6. So we can add them up. Okay, so 1/6 plus 1/6 plus 1/6 plus 1/6 is 4/6. So we just simply add the numerators and copy the denominator. And 1/3 has a equivalent fraction of 2/6. So that will sum up to 6/6 or 1. So property number 2 is also met. So therefore, this one is a discrete probability distribution. Is that clear? Okay, let's have another example. So another table. So again, so 1/3 again is just simply 0.333. Property number 1 is met. Okay. So it is greater than 0 but less than 1 each of the probabilities. And for property number 2, we're going to add that one, that is 1 plus 1 plus 1, that is plus 1 plus 1 is 5/3 or 1.67. So the sum of all the probabilities is not equal to 1. It is greater than 1. So therefore, property number 2 is not met, and therefore this is not a discrete probability distribution. Is that clear? Okay. Okay, let us apply those properties in this problem. So a random variable x has the following distribution. So you have here the table. And you are asked to find k and probability of 2. Okay, so these are the table. So to find the value of k, we will apply property number 1. We know that the sum of all probabilities should be equal to 1. So we'll just simply add them up. So 0.1 plus 2k plus 0.4 plus 0.25 plus 0.1 should be equal to 1. So adding similar terms, 0.1, 0.4, 0.25, and 0.1, so that will give us 2k plus 0.85 is equal to 1. We transpose 0.85 on the other side, so that will give us 1 minus 0.85, and that will give you 0.50. And then to get the value of k, you just simply divide both sides by 2, and therefore k is equal to 0.075. Okay? Now, so we have now here the values for k. Now, for letter B, find P of 2. So we have here P of 2 is equal to 2k. So all we have to do is to substitute the value of k, which is 0.075. So that will give us P of 2 is equal to 0.50. Okay, so did you follow the procedure? Okay, I hope everything is clear. Okay, let's have another example. So this time, this is the table, and you are asked to find the P of 2 and P of 4. So as looking at the table, you will notice that the given probabilities are in fraction. Okay, but just the same, apply the property number 1. It should be all the probabilities, the sum should be equal to 1. So we just add them, 1 over 20 plus d over 5 plus 7 over 20 plus 3d over 20 plus 1 over 10 should be equal to 1. So in adding fractions with different denominators, we will get the LCD. And the LCD will be for 20, 5, and 10 is 20. And then we have an equivalent fraction. So here we have 1 over 20 is just copied. And then here you have 20 divided by 5, that is 4 times d. So that's why we have here 4d. And then 7 over 20 is copy. Copy also 3d over 20. And then for the last one, you have 20 divided by 10, that is equivalent to 2, times 1 is 2. Okay, so is equal to 1. Now, to remove the denominator, we can do cross multiplication. So we can multiply 20 times 1. So that will give you this one. And then we can combine similar terms. 1 plus 7 plus 2, that is 10. And 4d plus 3d is equal to 7d is equal to 7d plus 10 is equal to 20. Let's continue here. So you have 7d is equal to 20. Transpose 10, that will be minus 10. So that will give you now 20 minus 10 is 10. And then dividing both sides by 7. So d is equal to 10 over 7. So this will be the answer for letter A. Now to find P of 2 and P of 4. So we have here the values. So for P of 2, you have the equation d over 5. So we just simply substitute. So you will have d is 10 over 7 divided by 5. So these are, what do you call that one? Fractional form. In fractional form. Or complex fraction. So we can have 10 over 7 and then multiply by the reciprocal of 5. So that will give you 1 over 5. We can cancel out 10 and 5. So 10 divided by 5 is 2. And then we just simply multiply the remaining numbers. So 2 times 1 and 7 times 1. So therefore, P of 2 is equal to 2 over 7. Is that clear? Did you follow? Okay, so let's have now P of 4. So this time you have 3d over 20. The same procedure. So you just substitute the value of d. So you will have 3 times 10 over 7 divided by 20. Multiply this one first. So you will have 30 over 7. And you get the reciprocal of 20. That is 1 over 20. And you multiply them. And then again, we can cancel out 30 and 20. That will give you 3 halves. And then multiply 3 times 1 and 7 times 2. So therefore, P of 4 is equal to 3 over 14. Is that clear? Okay, so I hope you follow the procedure. Okay, this ends our discussion for today. So I hope it is clear. Kindly visit the Google Classroom for your output and then wait for the part 2 of this discussion. Thank you.